Hello everyone. So I am Megha AH from the Department of Physics. Today I will give a small demo on uh, whatever the software we have learned, that is the Gaussian software. So in that, so firstly I will open this Gaussian software. So we will try here. So automatically these two windows will open. So we have learned what the calculation of energy, frequency, what is the ground state energy, and to calculate the bond length. Okay, so to calculate the HOMO and LUMO. So what we have what learned these topics in this software. So for that we need to choose one molecule for that calculation. So I will choose what the CO2 molecule now. So by clicking this, you will get to know so how to select the molecular or the atom. So I will choose what the carbon here, and I will choose what as an atom. So same will be clicked here, and again I will choose what the oxygen atoms now. So I will choose what the single atom now. So the gray atom indicates what the carbon, and these two red atoms indicates what the oxygen atoms. Now I have to what choose the bond between these two atoms. So here there is a bond. So to select what the bond between two atoms, so I will choose what the two atoms here. So you know the bond is what doublet in what the carbon and the oxygen in the CO2 molecule. So I can specify the bond length here. So I will let it what 2.22 now only. So I will what symmetrize this molecule later. So again, so this oxygen and this carbon. So again it's a doublet one. Okay. So this is how the CO2 molecules looks like, a rough CO2 molecule. So I will what label the atoms, and I will symbolize these two. Okay, so this is what oxygen. Okay, so these are one, two, three carbon atoms and oxygen, and here there is oxygen in the carbon. Now I will what symmetrize this, and I will clean this. Means what, by selecting this option, so it will automatically select its what bond length. Means what, it will automatically set it to a standard CO2 molecule. We can calculate the energy for this molecule. So for that you need to what click what the calculate option. So there what Gaussian calculation setup. So in that, if you want to calculate energy, select energy. Then if you want to calculate frequency, then select frequency. So now I will calculate the energy, and I will select what I want to calculate the ground state energy. Okay, so this is as it is, and where the location of this file. So therefore that I will specify the location here. Okay, so I will select the file name as CO2. So again I will give a path for this where I want to give this I want to locate this file in the desktop, so that's why you save, then give submit now. Again give a file name as you have given before. So your job is finished. Click. So here there is what program will run. So this includes all the parameters like bond length, so homos, lumos, information. Okay. So now I will close the Gaussian window and I will open our new created what CO2 file. So this is how it looks. So I can rotate it anywhere. So if we want to calculate, if you want to calculate the energy of this molecule, click right side of what your mouse and go to what results and submit. So there you will get a small window will open. So there you will get to know what the electronic energy. So minus 186.52. So you can convert this into what the electron volt. Okay. The dipole moment is 0 dB. Okay, so I will do this. Then if you want to see homos and lumos, so click right side, tools, then MOs. Okay, there you have to select what load MOs from the existing CK file. Okay, then so you have to visualize highlighted what homos and I want to highlight what homo and lumo. So for that, so update. So this is how what the CO2 molecule of aluminum looks like. So if you want to save this file, you can save this. So better I will what I want to what create that background as a white. So that's there. Go to display format. There you will select what the background color as white. Then so surface you can what you can take what the mesh surface or transparent. Okay, so it is fully opaque you now. So you can what make it as a transparent also. So values means if it is positive, if to show the positive centers, so it will show, and if you want the negative centers, it will show the negative. You want both. negative and the positive centers will go off. So I'll remain as it is. So if you want to save this image, okay, okay, right click of the mouse, there you will get save image file. Again, I want to save this in the desktop only. Okay, save this. So they for this what molecule you can calculate what the bond length also. So if you want to calculate, so bond length of these two atoms means what the carbon and the O2. So the here you will get what the bond length of 1.284. Then if you want to what the calculate what between this center carbon atom and this O3 molecule O3 atom. So the bond length is of what? So 1.25 between what C1 and what here also that will give sorry earlier I have told what O3 but it is what now have rotated na. So this is what C1 and O2 and this is C1 and O3. So this is how the picture of what CO2 molecule looks like with the HOMO and LOMO and these are the what these are the example of what the program I have run for the methane. So methane I have done. You can take about the different angles of this molecule by rotating on this where this window opens at the starting. So you can set the angle and take the pictures. And from this software we can calculate the frequency of the molecule also. The stretching, how the molecule will bend. So we can also calculate those all parameters by this software. Thank you.